Hi guys, if you have questions, email me or write a comment.
Okay, I'm going to talk about the integration rules, basic integration rules. I'll write them on my own way, so read and listen carefully. Till now, we know two rules. The first rule was integration of any constant depending on x is equal to the constant times x plus c, which is a constant of integration. And the second one was integration of x to the power of n depending on x. This will always be x to the power of n plus 1 over the new power n plus 1 plus c, with an important note here: n should not be equal to negative 1. This rule works for any power except for negative 1. And the third rule now will be the negative 1 power, x to the power of negative 1 dx. What's the answer of this integration? Of course, before I answer that, you have to keep in mind that x to the power of negative 1 is the same as 1 over x. So how do I integrate this? Simply, if you looked at exponential and integration rules, derivative rules, you will figure out that this should be equal to ln absolute value of x plus c. So the integration of x to the power of negative 1 will be equal to ln absolute value of x plus c. Absolute value because we all know that the domain of ln should be greater than 0. So whatever inside logarithmic function should be positive. The fourth rule is the integration of an exponential function, e to the power of, I will write it in this way, ax plus b. So if you want to integrate an exponential to a linear power, this will be immediately e to the power of ax plus b, which is same over the coefficient of x, so it's over a and always plus c for the integration. Let me give you an example on this before we continue. Let's say I have an integration of 2 over x dx. How would I integrate this? And let's say I want to integrate e to the power of 3x dx. This one can be written as 2 times integration of 1 over x dx, which is the logarithmic rule. It's x to the power of negative 1 or 1 over x. So immediately this will be equal to 2 ln absolute value of x plus c. And this one is a direct rule for exponential, so it's the same over the coefficient of x plus c. I will give you the ways of integration later on, but let's finish the rules. Actually, till now, the rules are easy, and I'm sure that you know them. We did this one, constant. We did x to the power of n. We did x to the power of negative 1, which is ln. We did e to a linear power, which is same divided by the coefficient of x. Now, the fun part is the trigonometric rules. Since you know the derivative rules, then it will be much easier for you to remember these. If I said I want to integrate sine ax or sine ax plus b, whatever, let's make it plus b, linear. Sine ax plus b dx. Well, you have to ask yourself, sine is a derivative of what? Well, it's actually a derivative of cosine. So this should be cosine the angle right? So when you derive cosine, you should get negative sign actually, since we don't have negative here, so the negative will be for the answer of integration. And instead of multiplying by a, it will be divided by a, and of course plus c. So I'm sure that you know now what's the next rule. Cosine and angle. Again, ask yourself, cosine is a derivative of what? It's a derivative of sine, the angle. So integration of cosine will give you sine. Check. If you derive sine, you will get the cosine. And of course, we should divide by a plus c. What would the next rule be? Integration of secant squared and angle. And secant squared is the derivative of tan and angle. Divide by a plus c. Next rule will be integration of cosecant squared. I'm sure you know what's the answer now. It's negative cotan, the angle, divided by a plus c, because the derivative of cotan gives you negative cosecant. So integration of cosecant is negative cotan. What's left? Integration of secant and angle, tan the angle, depending on x. This is the integration of secant the angle, of course, divided by a plus c. And the last one is integration of cosecant and angle, cotan the angle, depending on x. That for sure will give you a negative cosecant the angle divided by a plus c. Actually, these are the basic rules of integration. Let's have a look at them again. Integration of constant will give you constant times x. Integration of x to the power of n, you just add to the power, add 1 to the power, divide by the new power. And that works only when x is not equal to negative 1. If x is equal to negative 1, then the answer of integration will be len. Exponential, which is the fourth rule, exponential with a linear power, it's the same, divided by the coefficient of x. Sine will give you negative cosine. Cosine will give you sine. Secant will give you, secant squared will give you tan. Cosecant squared, negative cotan. Secant tan will give you secant. Cosecant cotan will give you negative cosecant. These can be found from rules of derivative. Okay. Later on, let's have a look at how to integrate. So now, in order to be able to use the rules of integration, you have to do something before that. So before you integrate, make sure that the function is ready. What do I mean by ready? I mean it has no radicals, fractions, or identities. How am I going to do this and why? Now, if you have a radical like x to the power of 2 under third root, we have no rule that represents such shape, because the rule that we have is x to the power of n only here. So whatever you need to integrate should look like this rule. Same for all, of course. So what should I do when I have such such radical? You have to write it as rational exponent. Now you can apply the integration rule. What if you have a fraction with a power in denominator, like this one, 1 over x to the power of 7, you rewrite it as x to the power of negative 7. So whenever you have a power in denominator, it should be taken up with opposite sign. What if you have trigonometric function? What should I do? I should take it up also, but not with the negative power. I should take it by its value, like 1 over secant. We don't have an integration rule for 1 over secant. So what should I do? I have to write it as a cosine, and we do have an integration rule of cosine. Same thing for 1 over cosecant. I rewrite it as sine. Now, 1 over cosine squared. We don't have such a rule. So what should I do with this? I rewrite it immediately as secant squared, and secant squared has a rule of integration. Same thing for 1 over sine squared. You rewrite it as cosecant squared. Let's check that. Do we have a rule for secant squared? Yes, actually, here are the rules for secant squared and cosecant squared. We have a direct answer for these. Okay. What about if I have an identity? Okay, now if you have any of these that comes alone means either the integration of cotan only or cotan plus or minus something, because addition and subtraction can be separated. So if you have any of these alone, what should you do? You have to rewrite it immediately using its identity. If you have tan, you have to write as sine over cosine. I will talk to you later about how to integrate division. And cotan, same thing. If you have tan squared, should be rewritten as secant squared minus 1. We have rule for secant squared and for 1. Cotan squared should be written as cosecant squared minus 1. Sine squared, we don't have such a rule, so I have to replace it using double angle formula. So it will be half times 1 minus cosine 2x. Cosine squared using the same double angle formula, but with addition, so half times 1 plus cosine 2x. So I'm using cosine double the angle here to rewrite this. So this is what I have to do when I need to integrate. I have to make sure that the function is ready by taking away all radicals, fractions, identities, rewrite them. Okay, so let's have an example on these. For example, if I said I need to integrate 1 over x to the power of 7 dx. How am I going to integrate this? The first step will be making it ready. So this will be integration of x to the power of negative 7 dx. And now I can use the power rule. So x to the power of negative 6 over negative 6 plus c. And of course, you need to simplify. Okay, what if I have integration of square root x to the power of 2 thirds dx. Again, we need to get rid of the radical, so this will be integration of x to the power of 2 thirds dx, which means I have to add 1 to the power x to the power of 5 over 3 over 5 over 3 plus c, and what if I have integration of 1 over secant x? This is a fraction, but it's trigonometric function, so I have to rewrite it using its identity. 1 over secant is cosine x dx. So this can be done immediately. Integration of cosine is sine x plus c. And if you have one of the identities, let's say integration of sine squared 5x, for example, dx, I have to rewrite it using double angle. So this will be half times 1 minus cosine double the angle, so 10x. And we know that half is a constant, so it can be taken out, the integration. So that will be integration of 1 minus integration of cosine. Integrate each one alone. Half, of course, half for everything. So half integration of 1 is x, integration of cosine is sine, divided by coefficient of x, and you can write plus c for all of them because plus constant here plus another constant here, you can just say plus a constant in general for all of them. And that's it for now. Okay, now your question would be how to integrate 1 over cosine squared x depending on x. What's the answer for that?
Remember to like, share, and subscribe, and write your questions via email or comments.